In previous videos we saw how to write a program and how to set up the CanSat in order to get a voltage reading from the thermistor, which we intend to use to measure temperature. We're going to have a quick look here at what we did. So there's our program. I open the serial window and we can see the voltage readings coming in. And as I showed you before, if I put my finger on the thermistor there and warm it up, we can see the voltage readings dropping, which makes sense because it's a negative resistance thermistor. Now, what we'd like to do would be to be able to change that voltage. So instead of a voltage reading, we get a temperature reading. To do that, we're going to need to calibrate our circuit. So what I mean by that is we're going to have to compare our voltage readings with known temperatures and then establish a relationship between them, possibly get the line function between the voltage and the temperature. To calibrate our circuitry properly, we're going to need a reference thermometer. So I'm going to use this one as an accurate thermometer to compare with. Now, for the CanSat competition, we'll be measuring temperature outdoors. So we might expect anywhere in Europe. So we might expect to be able to measure a range, that we should be able to measure a range of temperatures from maybe -15 to +35 Celsius. So I need to try to simulate as much as that as I can. So the best I could come up with was I'm going to use a hairdryer and a fridge freezer to raise the temperature and lower it. Okay? Now you may come up with better plans of your own, but we need something to give us a range of temperatures. So the plan is to record the voltages reported by the Arduino against the temperatures on the thermometer, and then to derive an equation of a line relating the two, which we can then use in our Arduino code to convert future voltage measurements into temperature measurements. Okay, so let's get started. So in order to reduce fluctuations in temperature caused by drafts and air currents, I decided to put everything into a little box. So I have a little cardboard box here. I'm going to put in the Arduino. Now you could use it with the radio transmitter if you like, instead of the cable. And here I have my thermometer. So I just made a small hole in the box here to insert the probe. So I have the probe positioned in the air very close to the thermistor. And then I'm going to get the lid on that as best I can. So at the same time, I'll open up the serial window here so I can see what's going on with the temperature readings. I'll turn on the thermometer. Okay, I'll switch on the hairdryer. I'm going to hold it at a constant distance from the box and keep an eye on the measurements. So I'm going to wait until it stabilizes, because the temperature in the box will come to some maximum. Once it stabilizes, I'm going to switch off the hairdryer and I'm going to log temperature, voltage on screen versus temperature on the thermometer in my notebook. So from the hairdryer end of the experiment, I've got a good range of sample data above room temperature. Now we need a sample going below room temperature. So to do that, again, I use the same setup. I put the box into the freezer, I close the door, and I watch the temperature drop. Again, when it had dropped to a sufficiently low, stable temperature, I took the box out of the freezer and again noted the voltage versus temperature. Every time the voltage changed on screen, I noted it and the temperature. So now I have a complete set of data. In my case, I got temperatures from -5 to +34 of thermistor voltage against temperature. The next step will be to take that to Excel to analyze the data and find an equation that will convert voltage to temperature reasonably accurately.